Spotlight, a intraoperative stereoscopic visualization. Here we can see a motion-tracked ultrasound transducer. The pink box is the rudimentary version of the housing. Underneath it we see a simulated live ultrasound scan. We can also draw a plane of the preoperative CT, which is coplanar to the ultrasound scan. So I can navigate the preoperative scan using the ultrasound probe in the sterile field. Here the registration is perfect. That's only because it's a simulated ultrasound. In the real world we expect some misregistration based on whichever registration technique that we're using. We also have a volume visualization, and that is specifically designed for intraoperative use. Typically, one doesn't use volume visualization intraoperatively because the structures that are in front occlude the structures behind, and that may be where the physician is working at that point. So Spotlight resolves this. Rather than using something like preoperative segmentation, it draws the structures where the physician is working, where the ultrasound probe is, opaquely and sharply. You can see I'm hovering above the left kidney, whereas there's another kidney on the right, and that is drawn transparently and out of focus. So the structures that are in front, you're still aware of them, you're still aware of their rough spatial position relative to you, but they don't occlude the structures that you're actually working on. We also have an intraoperative annotation capability. Rather than being used with a mouse at the workstation, this is intended to be used with a draped touchscreen in the sterile field that the surgeon, for example, could even use with a bloody finger. Here I'm going to annotate. I'm going to circle the right kidney with my finger. These are approximate annotations, not that are used informally. They wouldn't be used, for example, to compute the volume of a tumor. By circling it in two different planes, we can have a good notion of its shape in 3D. I'll also mark a tumor right here. And we can also even annotate structures that don't fit into a single 2D plane. So for example, there's 3 blood vessels in this liver phantom, and by simultaneously moving the ultrasound probe and following it with my finger, I can trace these structures. Again, it's informal and approximate, and here I'm going to, because it's informal, I'm going to give myself a reminder by drawing an arrow to come back and look at this more closely. So just like the volume visualization we saw earlier, the annotations also are transparent and out of focus when they're far from where I'm working, but they're sharp and in focus when they are near the ultrasound plane. Since this is a intraoperative visualization, in addition to tracked ultrasound, we have a motion-tracked needle. And here I can use the needle to navigate the preoperative data set. Again, the needle will be presumably sterile and in my hands already, or in the physician's hands already. I can change the cutting plane by spinning the needle along its axis, and the same is true for the volume visualization. That can be keyed to the can be manipulated using the needle. Finally, this of course can be used to target the needle as well, not just navigate the data set. So the tumor that I marked earlier, I will now try to place this microwave ablation needle into that tumor. And you can see we're very close to the end of that blood vessel, so I do need to be careful to avoid that while still centering the needle in that tumor. So I can do all this planning outside the patient by just holding the tip of the needle on the patient's skin. And then once I'm properly lined up and happy with my trajectory, I can place the needle into it. So now the tip is properly in the phantom's tumor, and we can turn on the simulated ablation volume, and we can see with this particular needle it's not centered on the tumor, and that's because the center of its volume is actually up the shaft a little bit, and that would be otherwise hard to understand. But so now I see that I need to sink the needle in further, and I can get an idea of by spinning the needle what tissue is inside the ablation zone. I can see I'm actually still very close to that blood vessel. So by reducing the power on the ablation generator, we can still have enough margin around the tumor while being while fully encompassing the phantom's tumor. And that's basically the features of Spotlight's intraoperative